Welcome everybody, it's Rev. I don't know if I'm going to make this video private or public or anything like that, but I just wanted to go through some Dustshoot math that I've been doing. And before I start the video, I kind of just want to preface it by saying um, this is a scenario analysis that requires a ton of different assumptions. So if you disagree with the assumptions, you can kind of tweak them to your liking. Um, The other thing I will say is because it does require so many assumptions, there's not really an exact answer on anything. Um, kind of, kind of what I went into when doing all this was trying to determine the optimal number of dust shoots to main and whether or not there were diminishing returns to dust shoots, which I frankly didn't get the answer to. But there, I think, are a few key takeaways on um, I guess stuff maybe you already knew. But there are going to be a lot of different assumptions here. And I'll start with, I guess, a few of the assumptions I made, which I started off with basically copy and pasting the data from War League Season 2 and Season 3, which is all that I had access to. And I didn't like clean up the data or anything, but these are basically the played rates for, and this is going to be a big input on what the expected value of Dust Shoot is as it progresses throughout the game. But Chaos Turbo, which is 42% of the meta in Season 2, Warrior was 22, Goat Control was 7, Chaos Control was roughly 6, and then Season 3, uh, this is the output for, oh shit, for each of these, and then this is just the mean estimate of what I assume the meta is going to look like. Um, I think this is one of the biggest inputs to the output we're going to have here in a few minutes. Well, all of these numbers are. So as you can kind of see, they don't add up to 100. So I just kind of went with this, which is Chaos Turbo is going to represent 45% of the meta, Warrior 25, and the two control variants 5, and then Rogue 20. I guess I could have broken it out with like RGT and like Burn maybe, but I just kind of split the difference and said Rogue is Rogue, and that's about a fifth of the meta. And I don't think you can really make like a good, like solid call on whether or not Dustshoot is good versus that Rogue portion because it's like really good against stuff like Cat, RGT, but it's like bad versus stuff like Earth Aggro, um, and pretty much everything else. I know I'm not thinking of every Rogue deck off the top of my head, but I'd say it's kind of like a 50-50 split. So I didn't think there was really any use in separating the output, um, or separating the assumption of like what that breakout is going to be. Um, and I did this a few days ago, so I'm gonna have to refresh myself. But it's important to weight this by the meta, just because like Dustshoot's obviously bad versus Warrior, and it's obviously good versus Chaos Turbo. So when you're doing like an expected value, you have to weight it by the meta, which is what some of these numbers are here in a second. And then I made a few other assumptions, um, which is the expected value of what drawing a Dustshoot is, and this is where things get very hairy, and depending on what number you want to assign to it, can really warp how valuable Dustshoot is. But Dustshoot, when resolved, is of course a one for one, but in my mind, it's a theoretical, like more than like it's not like probably a +1, but like in this output, what this number where my cursor is a +1. Like resolving a Dustshoot, I'm just saying theoretically is a +1. And a dead Dustshoot is a negative zero point 0.9. And the reason I kind of made the estimate on a negative zero point 0.9 was a Dustshoot can be discarded for things like Regeki Break or Tribe or um, like Charity, or it can be used to bluff, which has some value inherently in it. So it's not like a pure -1. But like in game terms, like a dead card is a -1. but I just didn't figure I would give it the full value of like a -1 just because there is some utility in like bluffing discards, card destruction, things like that. Um, Now, where this assumption kind of gets into like a few different things is I ran this with the expectation that resolving a dust shoot is a +1, which I don't believe, frankly. So I ran it down here with the assumption that dust shoot is a plus 0.75, and then I ran it with the assumption that dust shoot is a plus 0.5. And I think zero point 0.5 is probably the most accurate output because like when I was thinking if I had to assign a number to a resolved dust shoot of like whether or not it's like a plus like zero point 0.5 or like a plus zero point 0.2 or something was first you're not sending back a random card, so that does have some expected value that's above 0. You're sending back their best monster, like you're choosing and like seeing what's in your hand, what's in their plan or hand, and the field state. So I'd give that like a probably like a plus 0.15 if I had to throw a number on it, because you're not just sending back a random card. You're sending back their best monster. And then secondarily, the most important part is that you're getting hand knowledge. And I was trying to come up with like what like a, a numerical number would be for hand knowledge, but assuming that the average hand size when you resolve dust shoots like 5, just because sometimes they're going to have more, sometimes they're going to have just 4. Um, and then I guess since you're sending a card back, that you're probably only getting hand knowledge on 4 cards. If you had to assign a number on like for each card what that hand knowledge would be, I would say it's probably zero point 0.1. So like 4 cards at 0.1 is 0.4 plus the 0.15 is what my estimate of like the expected value of dust shoot would be. So we'll just round it down actually and just call it like about a 0.5. I would guess is like what the theoretical plus is from resolving a dust shoot because it's a number above 0, um, but you just really kind of have to like intuit like what that number is, and that's a really big assumption. Because if you run it with like a plus point, like a +1, like this top output, like you get some crazy values. So that's one assumption. Next are basically running a few different scenarios with the probability of drawing it with one in deck, going first, and then going second, drawing one in deck, and then the probability of drawing two in deck, going first and second, and then of course 3. And here is where I'm making a lot of other assumptions, which is that versus Chaos Turbo, um, it's going to be live for roughly 6 turns, which you can either think is correct or incorrect, and you'll be able to kind of directionally see which way this shifts the output if you think it's right or wrong. If you're going first versus Warrior, it's probably not going to be live past turn 2, so this theoretically would be a +1, or in this case, like a minus 0.9 if you dead draw it in the later turns. And then just assuming that the average turn count for any game is theoretically about 8 turns. Um, and then these numbers get significantly worse, by the way, if you were to model this out over a longer amount of turns, but you have to remember there are more turn 1s and turn 2s and turn 3s than there are turn like 10s or something. So these have to have kind of a higher weight. You kind of have to like, because the number of turns is like skewed lower, like on average. So you kind of have to cut it off above turn 8, because if you model this out like 30 turns, like the likelihood of there being 30 turns is very low, but it still carries the same weight with expected values, so it's just like not even worth modeling out like this far. Um, and I'm just gonna scroll down actually to like the output that I think that matters the most, which is the 0.5s, just because that's my estimate on what the expected value is of resolving a dust shoot, like a plus 0.5. Um, so I know this is a lot, but here are the expected meta weights. Here is on turn 1, the expectation if you resolve a dust shoot that it's a plus 0.5. Versus Warrior, if you're going first, turn 1, if you're going first, you probably can resolve a dust shoot and plus off of it. in this output, I'm just assuming after turn 1 your dust shoots are dead. And then I'm doing that basically for every single matchup. So with Chaos Control, I'm assuming that dust shoots going first are live for the first, where is it? Uh, Chaos Control first 4 turns, and then they're dead every turn thereafter. And then for Goat Control, I'm assuming they're live for the first 3, which might be stretching it, and then dead every turn thereafter. And of course, in like real games, like there's going to be a turn 7 when it's live, and then like turn 2s where it's dead. But I just figured like out of 8 turns, 3 of them probably. Or Goat Control, it's live if you catch my drift, and then Rogue the first 2 turns, just because Rogue does skew more aggressive. Um, and Rogue also skews towards ending the game more quickly. So that's that. So that's, I think, an explanation of what's going on here. The meta weights, the expected value of a resolved dust shoot, it being positive if you resolve it, it being a negative 0.9 if you have a dead dust shoot. And then here's the probability of drawing the dust shoots on turn 1, assuming a 6 hand card size, and then the marginal probability of drawing an additional one. And this was something I kind of had to like theorize on a little bit, which is that like if you like the cumulative probability of it, because like you could draw it, like you have a 15% chance of drawing it turn 1. I probably should have pulled up the Yu-Gi-Oh calculator I was using for this, but like you have a 15% chance of drawing it turn 1, and then when you have 34 cards left, assuming you didn't draw it, you have a like this percent chance to draw it. But it's not this exact percent chance because um, like basically I just took like a straight line estimate because like next turn it's going to be 33 cards, and then you have to make the assumption that you didn't draw it as well, which is very hard. Like if you were to like do a simulation of this, like some of these would be zeros and stuff. So I basically just ran the probabilities of like drawing it, assuming that you hadn't drawn it, and then just like kind of averaged them for these, which again is a kind of, actually this assumption isn't that actually extreme. This is actually like pretty close to what the actual number would be, assuming that you run 1. Um, and then like for example, like the probability of running 2, you have a much higher probability of drawing it, and then higher subsequent probabilities of drawing it too. So this actually, like this assumption's like not really that much of an assumption. It's just like a rounded number, so it's probably correct. Um, and then below here is what the expected value is on turn 1. So that's the probability of having the card, and then what the expected payoff is, which is the expected value. So like this times this, and then like just to show you, like warrior is like the expected value on turn 1, and then like if it were turn 2, it's just these two numbers multiplied by each other, and then you just basically run them all. And then here is the sum of all those numbers. So like this is just all of the probabilities over 8 turns of Chaos Turbo. Um, sorry, the sum of all the expected values of Chaos Turbo, which again is just this number times this number, and then you just sum them all over 8 turns. This is warrior, and this is like I think another thing that's kind of useful for the output, which is that like going first or second, like with I think somewhat realistic assumptions, it proves that dust or the trap dust shoots good versus chaos turbo, which is no news. So like at least the numbers like kind of match up with reality. And well, hold on, it's probably better to compare these two, because this is going first versus second. And I don't think there's that much of a difference in what the expected value of dust shoot is in a chaos turbo matchup. But like if you look at like what my assumptions were for warrior, the expected value is slightly negative um, versus warrior going first, but it's very negative. Whoops, it's very negative versus going second with warrior, just because it's dead for that one additional turn um, in like these assumptions. And then here's where the fun part comes in, which is you weight it by the meta. Um, just because you don't want to give as much weight or credence to like the chaos control or goat control output, just because it's a smaller part of the meta. So what I did was take this number times this number, and then this is this output. So like I'll show you here, which is basically taking what the expected value is and multiplying it by the expected weight in the Chaos Turbo meta, or the Chaos Turbo meta, just the meta. Um, and that's what this output is. And then you add them all up and you see if you get a positive or a negative number. And if it's a negative number, um, then you add it. Um, oh, I guess I skipped over a part, which is that you have to take this output and then average it with the output on going second, just because you have a 50-50 probability of going first or second. So I'll go through all of this again just to let you know what the outputs, but this is the final output here, which is just the average of these two numbers. So yeah, because you have to probability weight it and meta weight it and weight it by the expected value. So you're kind of like having to do a triple weighting on this. So the output here, which I think is the most realistic output, is in game um, or with one Dustshoot in your deck, the expected value is negative. If you assume that the payoffs are 0.5 and negative 0.9, um, if you add another Dustshoot in your deck and you get to 2, it gets more negative, and then at 3, it gets even more negative. The interesting part, I think, is that if you assume the expected value of a trap Dustshoot is 0.75, then having one Dustshoot in your um, deck has a positive expected value. Having 2 has an even more positive expected value, and then 3 has an even higher expected value. Um, I think it goes without saying is if you like just assume that trap Dustshoot is a +1, it's going to have an even higher expected value, which is this, and then running 2 is this, and then running 3 is this. So um, the the takeaway of this, I think, um, just because there are so many assumptions with something like this, is that the better player you are, probably the higher payoff is for you. Because that's like the number one variable. Well, there's two main variables to consider, and this is more of a meta call, but it kind of gives you a theoretical framework on like what to think about, which is that the higher you think this number is, like the plus, like if you're really, really good, like if you're one of the best players in the game, this is probably more than 0.5. Like this is probably 0.6 or zero point 0.7. And then for you, because you can do more with hand knowledge than other players, this is going to be a higher positive value. Um, the other big assumption is what you think the meta weights are going to be. And not only just what the meta weights are going into something like a tournament, but what the meta weights are going to be at the top tables of the tournament. And frankly, with the way I'm seeing the meta shaking up, like I don't like I would be surprised if Chaos Turbo wasn't more of the meta moving forward. So if you think Chaos Turbo is going to be more of the meta, let's say you think it's going to be 60%, that's going to give a higher relative weight to Chaos Turbo, and then it's going to have a higher expected value here, and then this is going to turn positive. So, if you think that Chaos Turbo is going to be a much bigger part of the meta and Warrior is going to be a much smaller part of the meta, this number gets big quite quickly. So really the two main variables to pay attention to are, what your assumption of what the expected value is of, these numbers, and then what percentage of the field you think is going to be hurt by trap Dustshoot in a positive way. Um, well, positive for you, negative for them. So, I quite frankly don't think there are a lot of like big takeaways. Like kind of what I was looking for when I did this was whether or not I could mathematically prove or assume or theorize what the correct number of Dustshoots was. Um, but I think there are frankly just too many assumptions to make that call. Um, But what I think I did come away with was when you're making a dust shoot decision, what you think um, the meta is going to be. Because if you think it's above 45% of the meta, you probably should be running multiple dust shoots. And just because the payoff is so large with dust shoot, you probably should be running like more than two. Um, and then also, if you think that you're a really good player and you like theorize that your expected plus off of resolving a dust shoot at some point in the game is greater than 0.5, you should probably run more dust shoots as well. Um, if you think, you're maybe above average and this is like probably just a 0.5, maybe just consider it as a side card. Because the benefit of it being a side card is you can side it in your like best matchups, but this is more of just like game one theory, as I had mentioned. Like game two, like if you should have dust shoot like at that point based on the matchup. Like this is going into like an unknown field, so you kind of have to use probabilities. Um, I don't think there's really much else to say about it. I don't know like what else would be helpful here. Maybe I'll just kind of like review the numbers, which is that this is the field assumption, this is the payoff assumption, the drawn probability assumption, and then this is multiplying those two numbers. This is summing the numbers over the course of 8 turns. Um, this is probability weighting it for the meta, and then this is the sum of all of the probability weights, and then this is um, averaging the probability weights between going first and going second. So that's it. I'm kind of upset I spent this much time and like don't really think I have like an answer to the dust shoot problem, but I can keep trying to crack it. Thanks for watching.